Hey everyone, welcome back to the channel. This is Rahul. Today we are going to solve an exciting problem, maximum ascending subarray sum, using an efficient, easy to understand approach. If you are new here, make sure to like, subscribe and hit the bell icon to stay updated with more coding videos regarding DSA. Now let's get started. So here is our problem. The problem gives us an array of positive integers and it asks us to return the maximum possible sum of contiguous ascending subarray. So a subarray is contiguous sequence of numbers in an array. A subarray is ascending if every element is strictly greater than the previous one. Means the if we have ith element, the I plus one should be greater than I. Like that, it should go. So if you see here, these three are the highest considering to these three. Okay, so 30, 20, 50, 60. Here 50, 60, 65. So we are taking maximum subarray sum from these three. Now this one it's purely ascending, so we are just getting the sum from these. When it get mixed, we are taking the one which is max among these. So here it's 10, 11 and 12. Now that we understand the problem, now let's discuss our approach and jump into the code. To solve this problem efficiently, we will use a single pass approach with a sliding sum technique. Okay, first of all, we need to start with current sum and maximum sum. Later, we need to iterate through the array, means we are traversing. Then we are giving our logic like I already mentioned, first number should be greater than um, previous one, like that. So like that, we have to check and extend the subarray by adding the current to current sum. Otherwise, we have to reset the current sum to current value, like that. So after that, we have to keep track of the maximum sum encountered so far. At last, we need to return the maximum sum after the loop. Easy, right? Now, let's implement the approach in Java. Here, we have the solution class and we have the method max ascending sum with an integer array nums. Now, we have to initialize our current sum and max sum. So, current sum will have the first element. So int current sum terms of 0 and max sum. So it will store the highest sum encountered. So currently we have the maximum value as current sum because it's the first element in that array. Okay. So current sum. Now we need to iterate through the array starting from index 1 because already we initialized our first variable here. So for int I to 1 I less than nums dot length, then increment I. So we start our loop. Now we have to add our logic. Like I already mentioned, we have to check if current is greater than the previous one. if nums of I greater than nums of I minus 1, then nothing, we have to initialize, we have to add this current number to current sum. So current sum nums of I. Okay, we have to handle those conditions like if the current element is smaller or equal, then we have to reset current sum to start a new subarray. Else current sum equal to nums of I. Now we assign this value. Now after this we have to track the maximum sum. Means at every step we have to update the max sum in order to store the highest sum encountered till now. So max sum, we will use the math method, math.max current sum. Okay, so we're done. At last we are return the, just run it. So with this I will explain how it work. It will take this subarray at first. Okay, once it become C5, this will reset to the current sum reset to 5. Then it will check these three. So it will get these as the maximum subarray. Like that we are taking. Then it's a simple method because when it comes to time complexity and space complexity, time complexity is taking only big of one n because we traverse the array once. When it comes to space complexity, it becomes big of 1 because we use only a few integer variable. Since it's a because of this, it's a optimal and efficient solution, and that's a wrap. We successfully implemented an efficient solution for finding the maximum sum of an ascending subarray. If you found this helpful, make sure to like, subscribe, and hit the bell icon to never miss an update. See you in next video. Till that, happy coding.